Hey everyone, and welcome to another deep dive. This time, we're going way back, like billions of years, to explore how life on Earth even got started.
It's a pretty wild story.
Oh, I bet. We've got this source material that really dives into the science, but it's written in such a fun, engaging way. So what are some of the most surprising things we're going to learn about early Earth?
Buckle up, because we're talking about a sandwich theory for how life began.
A sandwich theory. Okay, you've got my attention.
Oh, and get this, the oxygen we breathe. Yeah, it used to be a straight-up pollutant.
Wow, okay, I am definitely intrigued. But first, let's rewind all the way back. Paint us a picture. What was Earth like in its very earliest days?
Imagine, molten lava everywhere. Volcanoes constantly erupting, asteroids just bombarding the surface.
Sounds intense.
Intense is an understatement. Our source actually describes it as, every Michael Bay movie happening all at once. Yikes. Not exactly a place you'd want to visit. But so this fiery hellscape, it eventually cooled down, right? How did that happen?
Right, so over millions of years, the surface slowly cooled and solidified, forming the first continents. And all that steam that was trapped in the atmosphere, it condensed and rained down, creating, the oceans we know today.
So we go from a fiery inferno to a water world. That's a pretty dramatic makeover.
Pretty dramatic is right.
All right, so now we have a planet with oceans. How did life actually emerge from all that? I remember learning about the primordial soup theory in school.
Yes, the primordial soup.
But you mentioned something about a sandwich theory earlier. What's that all about?
So the primordial soup, it's a classic idea, but turns out it might not be the whole story.
Oh.
Our source actually calls it total nonsense. For years, scientists were convinced that life arose from this random mix of chemicals in some warm little pond. But the problem is, there's not much evidence to back it up.
So if the soup theory isn't quite cutting it, what does this sandwich theory propose?
Okay, so picture this. Instead of chemicals just randomly bumping into each other in some prehistoric soup, imagine them clinging to the flat surfaces of crystals.
Crystals.
Yeah, crystals. Think of these crystals like a structured meeting place for molecules, almost like, a two-dimensional dating app, but for the very first forms of life.
So the crystals are playing matchmaker.
Exactly. They hold the molecules in place so they can interact and bond more efficiently.
Okay, I'm starting to get it. So this theory says that crystals provided a more organized environment for life to get started. But why is that more believable than the primordial soup?
Well, for one thing, it gives us a better explanation for how those complex molecules could have even formed in the first place. If you just have random interactions in a soup, it would be, incredibly inefficient. But on a crystal surface, everything is more organized.
Right, more chances for those successful reactions.
Exactly. Plus, there's actually some pretty compelling evidence from modern science that supports this idea. Deep-sea volcanic vents, with all those minerals, they could be acting as pressure cookers for life's ingredients, just like they might have billions of years ago.
Wow, that's incredible. So we've got crystals acting as these chemical matchmakers and maybe even life still forming in these deep sea pressure cookers. But how do we go from molecules on crystals to, actual cells?
Right, so that's where these tiny, chemical Tupperware containers come into play.
Tupperware? Okay, now I'm really lost.
The source mentions that fatty byproducts, they started forming membranes.
Ah, membranes, okay.
Yeah, and these membranes acted like enclosures for the evolving proteins, right? Keeping everything organized and preventing the building blocks of life from drifting apart.
So they were kind of like the original cell walls.
Basically. And that's how the first cells were born.
It's amazing how something as simple as a fatty membrane played such a huge role in the origin of life. So these early cells, they were like tiny pioneers, breaking free from their crystal parents and setting off into the vast ocean.
Exactly. These early cells, they were simple, single-celled organisms, but they were a massive step forward in the evolution of life. They could replicate, pass on genetic information, the whole deal. But their journey, was far from over.
I bet.
Early Earth was a dynamic, challenging place, and these pioneering cells, they were about to face a whole new set of obstacles.
Okay, now I'm on the edge of my seat. What happened next?
That's when things get really interesting. Enter the blue-green algae.
Ah, the original plant gang.
The pioneers of photosynthesis.
I'm guessing they were about to shake things up.
You could say that. They figured out how to use chlorophyll, that magical green stuff,
Right.
to convert sunlight into food.
What a game changer.
Right. Imagine the evolutionary advantage. Suddenly, these algae They didn't have to rely on scavenging for scarce resources. They could just make their own energy from sunlight.
Revolutionary. But you mentioned earlier about oxygen being a pollutant. Where do they fit into that?
Right. So photosynthesis was amazing for the blue-green algae, but there were some unintended consequences for everything else on Earth.
Oh.
See, as they thrived and multiplied, they started pumping out massive amounts of oxygen into the atmosphere.
So oxygen, something we need to survive, was actually toxic to early life. How is that possible?
Back then, most life had evolved in an oxygen-free world. Oxygen was highly reactive and messed up their cellular machinery.
It was like the original air pollution.
Exactly.
So this abundance of oxygen, it caused a major crisis for early life.
It did. We're talking widespread rusting of metals, messed up chemical systems, and a mass extinction. But, like with many things in the history of life, this crisis also had a silver lining.
Okay, now I'm really curious. What good could possibly come from a toxic atmosphere?
Well, all that oxygen, it led to the formation of something pretty important, the ozone layer.
Ah, the ozone layer.
It acted like a shield, protecting Earth from harmful cosmic rays.
So it was a catastrophe that ultimately saved us. Talk about a plot twist.
Life is full of them. It just shows you how seemingly destructive events can actually drive these amazing evolutionary leaps. And speaking of leaps, are you ready for another wild turn in the story of life?
Hit me with it.
Let's talk about sex.
Okay, now you've got my attention. Tell me more.
So for billions of years, life on Earth just reproduced asexually.
Right.
It was efficient, sure, but it also led to a lot of genetic monotony. Every offspring was basically a clone of its parent.
Not a lot of variety.
Exactly, and that made them really vulnerable to any changes in the environment. But then something remarkable happened. Sex entered the chat.
Okay, now I'm really intrigued. How did sex change the game?
At first, it wasn't about romance or anything like that.
Right.
It was just two cells swapping genetic material, a very basic form of, DNA exchange.
Like a prehistoric file sharing system.
Exactly. But this simple act had huge consequences.
So instead of identical clones, you started getting offspring with a mix of traits from both parents.
Precisely. This led to offspring with a much wider range of characteristics. Some might be faster, tougher, better at finding food. Variety was in, and evolution had all these new tools to work with.
It's amazing how something so simple had such a massive impact on the course of life. But how did we get from this basic exchange of genetic material to, the more complex forms of sexual reproduction we see today?
Well, that's where things get even more fascinating. Over time, some cells evolve to specialize.
Specialize?
Yeah, they split into what we call gametes. These are like tiny half cells that carry only half the genetic information.
Okay.
And these gametes, they weren't content to stay single. They wanted to merge.
So when two gametes combined, they created offspring with a full set of genes, a mix of the best traits from both parents.
Exactly. And that is how sexual reproduction, as we know it, came to be. It wasn't about love or pleasure at first. It was all about survival.
Before we move on, I wanted to touch on something you mentioned earlier about the ozone layer. You said that all that extra oxygen led to its formation, but how did that actually happen?
Oh, that's a great question. So it's all about chemistry, really, and a bit of cosmic luck, I guess you could say.
Yeah.
As oxygen levels rose in the atmosphere, some of it reacted with UV radiation from the sun.
Okay.
And that interaction split some of the oxygen molecules, O2, apart, creating single oxygen atoms.
Right.
And then these single atoms, they combined with other oxygen molecules to form ozone, O3.
Oh.
Yeah. And ozone is pretty amazing because it absorbs most of the sun's harmful UV radiation.
So basically a buildup of this, initially toxic gas ended up creating a protective shield for the planet. That's kind of ironic when you think about it.
It is. It's a perfect example of how everything on Earth is interconnected and how what seems like a negative event can sometimes have these, unexpectedly positive consequences.
Yeah.
But let's get back to those early life forms for a minute. We left off with the introduction of sexual reproduction.
Right, which was a total game changer for the evolution of life.
Definitely a game changer. But, were there any organisms that just stuck with the asexual approach?
That's a good point. I mean, it seems like such a drastic shift. I wonder if there were any holdouts who just preferred, the simplicity of cloning themselves.
You might be surprised. Even today, plenty of organisms still reproduce asexually.
Really?
Oh, yeah. Bacteria, they're masters of cloning. And even some plants and animals can do it. It depends on their environment and the evolutionary pressures they face.
So it wasn't like there was this one moment when everybody switched over to sex. It was more of a gradual process.
Exactly. Think of it like trying different strategies in a game. Some species stuck with asexual reproduction. Others found that mixing things up with sexual reproduction gave them an edge.
Okay, makes sense.
And over time, as environments changed, the ones who could adapt best, they were the ones who thrived.
Survival of the fittest.
That's it.
Okay, so let's dig a little deeper into the benefits of sexual reproduction. You mentioned that it increased diversity and adaptability, but how did that actually play out?
Okay, so imagine you have a population of organisms that all reproduce asexually. They're basically all identical clones, right?
Where?
Now, let's say a new predator comes along or there's a disease. Because they're all genetically the same, they're all equally vulnerable. So, if one gets wiped out, they all get wiped out.
Makes sense. It's like putting all your eggs in one basket.
Exactly. But with sexual reproduction, things are different. Because offspring inherits a mix of genes from both parents, there's this wider range of traits in the population.
So some individuals might have genes that make them, say, resistant to a disease or better at escaping from a predator.
Exactly. So even if a disease or predator wipes out some of the population, there's a good chance that some will survive, because they have the right genes.
It's like a natural insurance policy for the species.
That's a great way to put it. And this ability to adapt to changing environments, that's what allowed life on Earth to evolve into all the amazing diversity we see today. From the tiniest bacteria to the tallest trees to, intelligent beings like us, it all goes back to this incredible power of sexual reproduction.
It's pretty mind-blowing when you think about it. It really makes you appreciate how complex and ingenious life is, even at its most basic level. We've covered so much ground today, from the fiery beginnings of Earth to the emergence of cells, the rise of oxygen, and the evolution of sexual reproduction. It's incredible how all these events, even the seemingly catastrophic ones, played a role in shaping the course of life.
It really is. It's a story full of twists and turns and unexpected consequences and remarkable adaptations. And it's still unfolding, even today.
That's true. Which brings me to a question that I've been thinking about throughout this whole deep dive. If life could emerge from such harsh beginnings and overcome so many challenges, what does that say about the possibilities for life beyond Earth?
Oh, that's a question that has fascinated people for centuries. And the fact that life arose here on Earth, even under such extreme conditions, suggests that it might not be such a rare phenomenon. I mean, perhaps somewhere out there in the vastness of space, other forms of life have taken root.
It's exciting to think about.
It is. They're facing their own unique challenges and finding their own incredible ways to adapt and evolve.
Are there any scientific theories or discoveries that, actually support this idea of life beyond Earth?
Well, there's no direct evidence of extraterrestrial life yet, but there are some tantalizing clues.
Like what?
Well, we know that the building blocks of life, organic molecules like amino acids, they're found in meteorites and comets.
Interesting.
And we've discovered thousands of planets orbiting other stars. And some of them might actually have conditions that are suitable for life.
So the ingredients are out there, and the potential habitats exist.
Exactly. It's just a matter of finding the right combination.
I hope we find it someday.
Me too. And with all the new telescopes and space exploration missions, we're getting closer all the time to answering that age-old question, Are we alone in the universe?
It's a humbling thought, really, and it makes you realize how much we still have to learn. So to wrap things up, I want to leave our listeners with one final thought. We've spent this deep dive exploring the incredible journey of life on Earth, but really, this is just the beginning. There's still so much out there to discover, so much to learn, so much to think about.
The universe is vast and full of mystery. Who knows what other incredible life might exist? What other chapters are waiting to be written in the story of life?
It's a truly humbling thought. And it reminds us that our journey of discovery is far from over. So keep exploring, keep asking questions, and never lose your sense of wonder. Thanks for joining us on this adventure.